All right. So example 3. I'm going to throw an equation at you now where a, the value of a is not 1. Watch. Y equals negative 3 x squared plus 6x minus 8. Negative 3x squared plus 6x minus 8. All right. Let's do it. A is not 1. So look at the move now. Here's the move. These first two terms, what can I factor out that'll enable me to make A to 1? 3. Watch this. If I factor out a 3, what ends up happening? 3 times what is negative 3x squared? Negative 1x squared, huh? But now notice, A is not 1 still. I want A to be 1. So 3 is not going to work. Something else has to work. Look at 3 times negative 1 makes negative 3x squared. But notice A is still not positive 1. I need to make it something else. Negative 3. Let's factor out a negative 3. So let me start again. Watch what happens if I factor out a negative 3. Negative 3. Now I can make this a positive 1x squared. Okay, now the A value is 1. Plus what? What would? Negative 2 or negative 3? Yeah, negative 2. Because we need a positive 6x, so negative 3 times a negative 2x. Right here, right? I'm going to leave a little space here because we're going to add the b over 2 squared. And I'll put the minus 8 over here. So I'll leave a space here. Okay. Look at negative 3 times x squared is negative 3x squared. Negative 3 times negative 2 is positive 6x. Cool. All right. Let's calculate now b over 2 squared. So calculating b over 2 squared, let me put on this side this time. So b over 2 squared. Right, so b is now negative 2. Very good. So watch this. So we have a negative 2 over 2. So we have a negative 1 squared. Negative 1 times negative 1, positive 1. Okay, so I'm going to add that and subtract that to the right side. But now here's that logical move I was talking about. Okay, think about what's going on. Let me bring my balance scale over here again. A trusty balance scale. So watch this. If I put a 1 right here, watch the move. If I put a plus 1 right here, what am I really adding to the right side if I put a 1 right there? A negative 3. Because look at negative 3 times this is that. Okay, negative 3 times that is this. But a negative 3 times a 1 is really a negative 3. So what I'm really doing to the right side, here's a logic now. This is why you take math, the logical skills. What I'm really doing is I'm adding a negative 3 to the right side. When I put a 1 right there, in this parenthesis, it has to be multiplied by the negative 3. So what I'm really doing is adding a negative 3. So what's the opposite of adding a negative 3? We'll subtract a 3 to offset it to make it balance. So I'm going to put a minus 3 over here. That's the move. That's the logical move you need to get right now. That's what makes it a little more difficult, a little higher level of thinking, but it's all logic. Okay? Let's do it. that for now. So we have y is -3 times, now we can factor this trinomial. This trinomial is factorable here, which will be two numbers that multiply become +1 but become -2 if I add them. -1 of x minus 1 times x minus 1. -1 times -1 is +1. Outside and inside become -2x. So I got a -3 minus -8 minus 3 is going to be a -11. So far, so good. Well, you know what? It's actually adding a +3, huh? We have to offset it. We have to add a 3. My bad. Right. Because -3 times 1 is subtracting 3, so the opposite is adding a 3. Right. Forgive me there. -3 times 1 is subtracting 3. That becomes a -3 added here when you multiply. So the opposite of subtracting 3 is adding the 3. Need more coffee there. So that becomes a -5, right? Plus -5. It's starting to look like vertex form now. Y is -3 times x minus 1 squared. X minus 1 times itself is x minus 1 squared plus a -5. Right, Picasso? Stay on it. So let's compare that with vertex form. Vertex form is a x minus h squared plus k. So the vertex is hk, yeah? Right, h is 1 and -5. There's your vertex. By the way, my A looks like a 9. Sorry about that. There you go. Okay, so get out your graph paper. I got extra copies if you need some more graph paper. This is our last graph for today. All right. So let's graph 1, -5. 1, -5 is right there. Okay. There's our vertex. Now what we got to find is our x-intercepts and our y-intercepts. Phone's away right now. Earphones off. Now what I want to do is just give you a little FYI right now about the parabola. Notice how on vertex form you have this a value. In this case, the a value is going to be -3. Okay. Whenever that a value is negative, the parabola opens down. That means the parabola is coming like this. If that a value is positive, that parabola is opening up. So on your notes, so all this work you're doing on your note paper, the graph you're just designating for the graphs. So right now on your notes, go to put a little star, put FYI. If A is positive, I'll put plus for positive. If A is positive, it opens up parabola. I'll draw a little parabola. If A is negative, it opens down. put a little star in the notes. Notice how this is in vertex form right here. And look at that A value. When I compare it with the vertex form, the A value is negative. If it's negative or positive, it tells me to open down or up. So will this parabola open up or down? It's going to open down because this is a negative 3. So if that's the vertex that we just plotted, and it opens down, that's the vertex, it opens down. I don't know about you, but using simple logic, it's never going to cross the x-axis. It's not going to cross the x-axis because this is the highest point. It's opening down. It's going to be looking like this right now. How it's going to look, we're going to find out. But this is the vertex. It's going to be going down like this forever. It'll never touch the x-axis. So when I find the x-intercept right now by replacing y with 0, something funky is going to happen, and I want you to pay attention. Watch. So let's find our x-intercepts. Remember, the x-intercepts, just like warm-up, we reviewed that. Something is always 0. The y is always 0. So let me rewrite the equation coming down over here. So y equals negative 3 times x minus 1 squared plus negative 5. So y equals, so that, let's see, 0. What am I doing? Okay, watch this. 0 equals negative 3 times x minus 1 squared plus negative 5. All right. We'll get rid of the 5, then we'll get rid of the negative 3, then we'll get rid of the 2 in that order. So to get rid of the 5, we'll add 5 to our equation, both the left and the right. That gets rid of it on the right. So we have 5 equaling negative 3 times the quantity x minus 1 squared. Let's get rid of the 3 by dividing by negative 3 on both sides. So I have x minus 1 squared equals negative 5/3. I'll just leave it as a fraction for now. Talk to me, Ms. Rojas. You see something funky? What's going on?
You see how it comes up in negative 3?
Yes.
Is this supposed to be positive 3? So you can cancel them out?
Well, I'm dividing, huh?
One,
If I was adding or subtracting, yeah. But here I'm dividing. So negative 3 divided by negative 3 is just positive 1. There's a 1 right there. Don't need to write it. Good question. Here we go. Let's take the square root of both sides. Now look at the square root of negative 5/3. That's a nasty number. I don't expect you to try to figure that out on your own mind. You're going to let the calculator do the work right now, like we did on warm-up. So stay with me. Watch this. This is gone. So I have x minus 1 equals, because the square root and squaring cancel each other out.
Oh, okay.
Yeah. So negative 5/3. Well, good question. Why is it negative? Well, a positive divided by negative makes a whole fraction negative. When the signs are different and you're dividing, it makes a whole fraction negative. But if the signs are same, if it was negative divided by negative, it would be a positive fraction. That's just fraction. That's fraction. Remember? Negative times a positive, negative divided by negative, positive is also going to be a negative. The signs are different, it's negative. Now, I'm going to let the calculator do the work for me here. Watch what happens. Something crazy is going to happen now. Watch. Here's my calculator. I'm going to hit the square root of negative 5/3. That's 5 divided by 3. So negative 5 over 3 is the same as negative 5 divided by 3. So I'm going to hit equal. Look what the calculator tells me. Error. Right, but it's no solution, and I want to talk about why.
We're going down.
Right,
And it
remember?
doesn't touch the X.
Right, so look at our graph. Let's see, where are we at here? So remember our vertex is right here, and A is negative,
So it goes
so it's going to go down. It'll never touch the x-axis, so we end up having no solution. That means, well, what it really means is this. You can't take the square root of a negative number. For instance, what's the square root of 4? If I press equal, it's going to 2, huh? But what's the square root of negative 4? Error. If you can think of a number multiplied by itself that becomes a negative number, you'll be world famous. You'll be in the history books forever. It'll be an error. So whenever you have the square root of a negative number, an alarm clock, a signal should go off in your head saying there's no solution. That means the parabola doesn't cross the x-axis. So watch. Here's what we're going to do. So on your notes, going to write no x-intercepts. So all we have right now is a vertex. There it is in red, all by itself.
That's it.
Hold up. No x-intercepts. There will be a y-intercept, though. It will cross the y-axis at some point. So remember, this is going down, so this parabola is coming down like that. So it's going to cross the y-axis somewhere, which we're going to find out now. He says -6. Let's find out. How would we find out for sure, though? I mean, what would we do?
No, I was just fine there.
Okay. Go ahead, Mr. Rojas. What? What should we do to find our y-intercepts? Make the x 0. Thank you, Camacho. Excellent. So let me rewrite the equation right here. Y. I'm finding the y-intercepts here. So y is equal to -3 times x minus 1 squared plus -5. Like Camacho said, at the y-intercept, Barcoba, the x is always 0. So watch what I'm going to do. -3 times 0 minus 1, I'm replacing x with 0, plus -5. We have a lot of decisions to make. So don't piss Aunt Sally off right now. Parentheses first. -1, 0 minus 1 is -1. Okay. What does Aunt Sally tell us to do now? Exponent, huh? Exponent. +1, huh? What does Aunt Sally tell us to do now? Multiply, huh? -8, yeah? We're graphing, so let's put in coordinate form. X is 0. Y is -8. There's our y-intercept. -8's right here. Remember, it was opening down, right? So it makes sense. This parabola is coming up to the vertex and coming down, like that. No x-intercepts. It'll never cross the x-axis.
Yeah. It's still probably.
Okay, I like that question. So Camacho's saying, hey, we did all this work to try to find x and there was no x-intercepts. What would tell you, so my answer is no, you don't have to do that. If you know there's no x-intercepts, you don't have to do this. But for the sake of people here are not as advanced right now in your thinking. What would have told you that you didn't have to do this here when we got to this step? Okay, A was negative. It's opening down. So it's opening down, huh? So you already know if that vertex is below the x-intercept or the x-axis and it's opening down, logically, again, what does matter? It's logic. You know it's not going to pass here, so you can skip all that part. So my answer is yeah. Save time. Go ahead and check your social media for about a minute. Take a stretch. Instagram, Facebook, Snapchat, Twitter. Go ahead. And you're going to do a table talk, small one.